Hello, my name is Sebastian Murgul and I am one of the authors of the paper Joint Transcription of Acoustic Guitar Strumming Directions and Chords. This paper is a collaboration between the company Klangio and the Karlsruhe Institute of Technology in Germany. Existing ISMIR models for note tracking excel at transcribing guitar fingerpicking, but they have some problems with guitar strumming, because strumming comes with challenges. First of all, we have a very dense polyphony. We are not only interested in the note that were played, but also in the stroking direction, and we have to deal with a lot of sloppy playing, since this playing style is especially popular amongst amateurs. Due to data scarcity, we also have only seen limited progress in the deep learning world. Therefore, we present a novel synthesis and multimodal recording approach to train a CRNN-based strumming transcription model. The multimodal data acquisition is done using an ESP32 smartwatch module, which is mounted on the back of the hand and records the hand's motion using a 3-axis accelerometer. We not only record the motion, but also the audio using a microphone and the guitar's pickup signal, and store all of these signals in sync alongside with the metadata. We recorded 3 guitarists. They were instructed 28 strumming patterns with varying tempo, technique, and volume instructions. The annotation process is done in a semi-automatic way using spectral flux and motion derivatives and manual alignment in a user interface. In total, we recorded and annotated about 90 minutes of audio. Since this is not enough to train a state-of-the-art deep learning model, we also developed a guitar strumming synthesis pipeline. We use this pipeline to sample about 1000 examples, which is equal to about 4 hours of audio. It works by, first of all, we choose one of 51 chord progressions. This progression is then transposed to a random key. We apply a chord fingering scheme and then use one of 36 strumming patterns to render a tablature which is stored in the guitar profile format. We use these guitar profiles in the Ample Guitar VST and the DAW Dreamer library to create audio, which is then augmented using distortion, filters, compression, reverb, noise, and some playing artifacts. We use all of the created data to train a CRNN-based model, which is based on the model by Kong et al., which features basically 2 strains that process a log-mel spectrogram. The first strain is doing the action regression, which figures out when in time we have a down and up strumming action. And the second strain is doing a chord classification by the means of major and minor chords. We also apply a pitch shifting augmentation by 6 minor semitones in order to enrich our dataset. As a result, we were able to achieve an onset F1 score of 93% using only the microphone audio, and we get a chord accuracy of about 90%. By combining synthetic and real datasets, we were able to get the overall best results, and when applying the pitch shifting augmentation, we were able to improve our directional F1 scores by at least 10 percentage points. In future work, it might be interesting to expand the chord vocabulary, to add muted strums, and to scale the multimodal dataset. Thank you for listening.